To subscribe our channel, press the bell button, like, comment and share.
Very good morning. Welcome to the 16th Mydbops Mywebinar. Uh, Thank you for making it on a Saturday. Really appreciate that. So my name is Mohammed Zaid Patel, and today I'm here to talk about tuning Autovacuum in PostgreSQL. So let's begin. So that's me. I work as a database consultant here at Mydbops for the Postgres team for about a year now. I'm an active learner. I try to learn things and gain some knowledge. I am a technophile. I consider myself a technophile. I am passionate about technology and creating solutions using it. Very much intrigued in PostgreSQL and open source software. I really like the idea of people and communities coming together, building solutions and helping each other out. And apart from being a great database consultant, I also like playing cricket and listening to some music in the free time. So you can connect with me on LinkedIn at Zaid Patel, or you can scan this QR. Okay. So some briefs about MyDBOps for those who are attending my webinar for the first time and don't know what we are or what we do. So founded in the year 2016, MyDBOps is a database management and a consultancy provider. We provide services on top open source databases. We are a 80 plus member team who do not sleep. We are there to assist you 24/7. We are also AWS partner, PCI, and ISO certified organization. So MyDBOps basically provide two types of services. One is the database consulting, wherein we consult upon database management systems and related technologies. The other one is managed database services, wherein you get 24/7 database monitoring, remote DBA support, database optimization and scaling solutions, and much more. On top databases like MySQL, MariaDB, MongoDB, and Postgres on premises and both on cloud. So in 6 years of operation so far, we have catered to 500 plus happy customers in domains like e-commerce, edtech, logistics, transportation, fintech, and much more, both in India as well as abroad. So this is a small portfolio of ours. So hope that you are following us on LinkedIn. If not, you can scan this QR or you can follow us at mydbops.com, because we keep on coming with this kind of webinars and tech talks, which will be really helpful. So coming to the agenda of this talk, today I'll be discussing database bloat, what is vacuum, what is auto vacuum, why we need auto vacuum, and tuning auto vacuum, and then some best practices to keep in mind. Okay, so before jumping directly to the agenda, let's get some basics right so that we can have a better idea moving ahead. So not just in Postgres, any other database management systems, selects, inserts, updates, deletes. These are some of the common actions. So the selects are used to query the data, inserts to add, delete to remove the data, and updates we can update the previously existing data. Let's discuss updates a bit over here. So updates basically means deletion of an old value and inserting a new value in place of it. So for example, suppose a table Avengers with three rows and three columns. Pretty simple. So now a user A accesses the table and updates a value using this query. Suppose the third row is updated, name is set to blue, so ID equals 3. So this is the resultant table that we get, where you can see the new value over here. But at the database level, the table looks somewhat like this. Okay, so as you can see, the row third is not deleted completely. It is just marked as invisible, or in Postgres, as we say, dead. So in Postgres, the deleted rows are not completely removed from the table. It's just marked as a dead tuple. This is because the undo log is maintained inside the table itself, unlike other database management systems where the unravel log is maintained somewhere else in the memory location. So because of this, no space is reclaimed, and these dead tuples get accumulated over time. Now the question is why? Why just Postgres does not remove the data, and why it keeps it? So the answer to this is Postgres MVCC, or the multi-version concurrency control model. Here's an other example for this. Suppose consider our same O table where user A accesses the table and updates it. This is the table in the database level. Now, while this transaction is happening, let us suppose that another user B logs into the database. So so both of these users are parallelly accessing the database. So these we can consider them as concurrent users. So now, when user B accesses the table is somewhat like this, the previous version of the table, not the updated one, because user A has not yet completed the transaction or committed the transaction. So if user B selects the data that was being deleted, it will be visible to user B and it will not be deleted yet, because the thing is we cannot determine how long will user A take to complete a transaction. So Postgres cannot hold up to a certain user, and it allows concurrent users to access the data at the same time. So through this, data consistency is maintained, and like to maintain concurrent users, Postgres maintain a past image and a latest image of the data. As you can see, the user A accessing the user A for user A, the row number 3 is the name as Bruce, which is the latest version of the data, whereas user B is viewing the past version of data, which is Thor. So every row of Postgres has a version number that determines whether it is a past data or a future. Or through this, also transaction isolation is created so that multiple users do not view the inconsistent data of other transactions. So also logs required for querying the data or reading the data do not conflict with logs required for writing, and the data is available at the same time for all the users. So this gives rise to database bloat. So database bloat in general means the storage accumulated by the dead tuples, the tuples that were not removed. So as these dead tuples increase, the database bloat also increases. Here's a sample query to check database bloat, wherein you can write your table name over here, and the result will be the percentage of dead tuples. So why is bloat bad? The first thing is slow sequential scans. So when Postgres in sequential scans, when Postgres needs to scan all the table for the required data, here in this case it takes much more time because Postgres has to dodge all the dead tuples and then fetch the actual data. The second thing is it eats up the storage because the storage that was supposed to be cleared up after data removal is not. It is held up by the dead tuples, so the storage is eaten up. And the third thing is once the dead tuples increase in number more than the live tuples, we cannot update the table because no more transaction IDs are there. And the last and the most dangerous one thing is transaction ID wraparound. So let's discuss transaction ID wraparound here. So every row in Postgres contains a transaction ID header, which comprises of two parts, xmin and xmax. Xmin is the ID when the transaction was first created, and xmax is the ID when the transaction was last updated or last changed. So the difference between xmax and xmin give us the age of the transaction. So Postgres uses 32-bit transaction IDs for all the rows. So which is more than around 4 billion. So this might be a big number, but with databases with intensive workload, this can get filled up pretty quickly. So as you can see in the picture, the transaction starts from 1 and goes all the way to 4 billion. So at any point, transaction can view 2 billion transactions in the as the future transactions and 2 billion as the past ones. Consider an example of transaction number 3 here. So for transaction number 3, it can view the 1 and 2 as the past, and uh, the following 2 billion transactions as the future. So for transaction 3, transaction number 4 is in the future. Transaction 1 and 2 are in the past. So once these transaction IDs get around allocating to all the databases, we can see that for transaction number 4, 1 will be in the future because the transaction ID is now getting filled up. So in that case, a wraparound occurs when we reach 4 billion transactions. The next ID to be allocated should be 1, and Postgres has to start from 1 again. So here we can see a wraparound is occurring. So as we have limited transaction IDs, once the upper limit of 4 billion is reached, the IDs get wrapped around and Postgres needs to start again from 1. But it is difficult for Postgres to know if the upcoming transaction is a future one or a past one. Because here the transaction was not committed, the transaction ID is still being held up by the transaction. So it will be difficult to figure out for Postgres if it is a future one or a past one. So in order to protect the data, Postgres shuts down the database. So like this doesn't happen suddenly. Like we get warnings before 10 million transactions before the limit, and 1 million transactions before the upper limit, the database goes to read only mode. But once this happens, it is really a tedious process to bring the database back. So how can we remove this bloat? The answer is simple. We need to vacuum it. What is vacuum? So vacuum is a really important Postgres feature which helps in removing the dead tuples. It marks the tuples that are it marks the dead tuples and cleans them up. It is also used to reclaim the storage that were held up by the dead tuples. It also reclaims the storage back to the OS in some cases. We will discuss that further. And yeah, it comes with various options like this one. So this is the syntax of vacuum. We have vacuum. These are the options: hold, freeze, verbose, analyze. And then we can give the tables as well as the columns that need to be vacuumed. If we don't give any tables or columns, it will by default take it as a vacuum full, and complete database will be vacuum. Okay, so vacuum full. So this vacuum full vacuums and the entire database, and the space you acquired by data tuples is returned back to the operating system. The thing is, it is high on resource consumption. It requires good amount of CPU and memory, and also it holds up lock on the tables that are being vacuumed, so that are not accessible. It is slower than vacuum, and it requires extra disk space because in this case, vacuum rebuilds the old table, copies all the live tuples in there, and then drops the old table. So this requires extra space. So vacuum freeze, what it does is it marks the table's rows with a unique timestamp so that it can be determined if it is a future transaction or a past one. So that transaction IDs get freed up and that can be used for the newer transactions. But the next update on the table will unfreeze the IDs. So this is very helpful in transaction ID wraparound to bring the to overcome this. We can use a vacuum freeze. So so often verbose is just used to print the detailed activity report on the screen as it progresses for each table. So what analyze does is after a vacuum has removed all the dead tuples, analyze updates the query statistics so that the query planner can now use an efficient way to execute the queries. So is vacuum the perfect solution to this thing? Actually not. So here are some of the downsides of vacuum. The first thing is it is manual. It requires human intervention, and we humans are not that good in doing repetitive tasks or maintaining things. The second thing is it is high in cost. So as I said, it requires a good amount of CPU and memory and disk as well. The third thing it is employees locking on the table. The tables that are being vacuumed will not be accessible, and it also requires extra disk space in case of vacuum fault where we need to rebuild the table. So we certainly need something better, right? Because this kind we cannot work with this. So don't worry, Postgres community has got you covered, and now we have Autovacuum. So what is Autovacuum? So another really important feature of Postgres, which was first released in the version 8.3, it is a background utility that wakes up every minute by default and automatically executes the vacuum and analyze on the required table. So as this is not this is need not to be triggered manually. It is completely automated process. We just need to configure it once, and then this will take care. The thing is, it does not free up the space, but it reallocates the deleted blocks back to the FSM where it can be used for the new inserts. So this is a brief explanation of how things work. First, the auto vacuum launcher wakes up. It distributes the work across time, starting allocating one worker with each database. Oh, for every auto vacuum map settings. You can set this settings according to the database activity. Then maximum number of auto vacuum max workers are allowed to run at the same time on multiple databases, and tables and databases are checked and vacuum and analyze or vacuum or analyze as per the need is executed. So the functionality of auto vacuum completely depends on the settings that are available inside the Postgres or conf file. So here is the thing, you can also disable the auto vacuum on any table if required using this command. So why is auto vacuum better than manual? So the first thing is table bloating is prevented as this is a regular process. So with table bloating is prevented here as it clears all the dead tuples and all. No lock. It does not hold up locks on any tables, unlike vacuum. It is not that resource intensive like the manual one. It We can have better storage space utilization as the dead tuples have been cleared regularly. It improves the FSM or free space map, wherein the query planner can get the better query analytics, and the query execution can be done in a more efficient way. The most important thing, this prevents transaction ID wraparound, and as the transactions IDs are being freed up regularly, we get to see faster query executions because of the updated query plans. We have faster sequential scans as we do not have any dead tuples. With the sequential scans are comparatively faster, and we get overall better database performance. So finally, we'll see how we can tune auto vacuum. So this is the section of our auto vacuum in the postgres.conf file, where you can see all the variables with their default values are present along with a short description. Well, this might not be the case for the cloud hosted databases in Google Cloud or AWS, but this can be changed using the postgres.conf file in the VMs, or it can simply be changed using the PSQL terminal. Okay, so the first and most important thing is auto vacuum should not be off in any case. We don't do that. So, and unless you really know what you're doing with your database, we suggest not to turn it off. Okay, auto vacuum should be turned on always. And for this to work, there is a parameter track counts that should be turned on as well. Track counts enables the database to collect the statistics like inserts and updates, all those things. Okay, so the next one is auto vacuum threshold. This specifies the minimum number of updates or deletes that is required to trigger a vacuum in any of the table. For example, if I set this value as 50, so for every 50 tuples updated or deleted in a table, it will trigger a vacuum in that table. it will be triggered automatically by Autovacuum. So the next one is Autovacuum analyze threshold. Same thing. It specifies the minimum number of inserted, updated, or deleted tuples to trigger an analyze. Next one is Autovacuum vacuum scale factor. This specifies a fraction of the table size that will be added to Autovacuum vacuum threshold when deciding whether to trigger or vacuum or not. Then we have Autovacuum analyze scale factor. Same thing. We have this one specifies the fraction of table size to add to Autovacuum analyze threshold when deciding whether to trigger an analyze or not. Okay, so the next parameter is Autovacuum nap time. This is a minimum time between Autovacuum for which the Autovacuum sleeps and then it wakes up and runs the process all over again. By default, it is 60. So for every 60 means 60 seconds. So for every minute, Autovacuum wakes up and scans the database and does this thing. The next one is Autovacuum max workers. It specifies the maximum number of Autovacuum processes that can be run at a time. Okay, so then we have Autovacuum vacuum cost limit, which specifies the cost delay for or like the cost usage for Autovacuum vacuum operations. Once this cost limit is reached, Autovacuum will stop for Autovacuum vacuum cost daily seconds so that it does not add up to the resource consumption when the database is busy. Okay, so Autovacuum vacuum cost delay. So once the cost limit is reached, this we can set this parameter. Like once the cost limit is reached, Autovacuum waits for this much seconds, and then it continues back. Okay, so another most important parameter is max parallel maintenance workers. This parameter sets the number of workers that can operate parallelly by which can be started by a single utility command. So this variable takes care of the maintenance workers that are used for vacuum and analyze and that process. Okay, so the next one is hot standby feedback. This is used in the like in a setup of where we have primary and replica servers. This specifies whether to wait for the primary to like for the queries to get executed as the primary and do not perform a vacuum till then. So once the primaries are done with executing the queries, well, this parameter can be used to trigger a auto vacuum at the replica or the standby server. Okay, so overview of what we just discussed. Auto vacuum is on by default. Auto vacuum threshold that is 50 by default. It can be adjusted. All those parameters can be changed in the process of config. Auto vacuum analyze threshold, which is again 50. Auto vacuum scale factor, it is 0.2 or 20% of the table size. Auto vacuum analyze scale factor is also 0.2. Auto vacuum nap time is 60 seconds, which is a minute. Then we have auto vacuum max workers equal 3 by default. So by default, 3 auto vacuum processor can run at a single time. So auto vacuum cost limit is disabled or this -1. We can set this if we think our database is busy and we do not want auto vacuum to add up to the resource usage. The next one is auto vacuum cost delay. It is 2 milliseconds as default. It can be set accordingly. Then we have max parallel maintenance workers to be 2 and hot standby feedback is also turned on by default. So at the last, some best DB practices to keep in mind. The first one is to detect the bloat. So we should have an idea of bloat on the tables that are generally being accessed more frequently than the others. The bloat should be I just at the start I just shared a query that can be used to check the bloat in the tables. So the bloat should be detected so that we can plan on triggering vacuum or analyze on those tables. The next one is we should configure auto vacuum that should be suitable for most of the tables. Like for example, setting auto vacuum threshold, setting a auto vacuum scale factor as 0.2 for a table with 10 rows is good. Like for every 2 rows updated or deleted, it will trigger a auto vacuum. But the same, but setting the same for for a table with like a billion rows is like does not make sense, because for every two around every 2 million rows, it will for every update of 2 million rows, then it will trigger a vacuum or analyze. So the auto vacuum should be configured that stores most of the tables in the database. So the next one is maintenance windows. So if a database is like really busy during the peak hours, and we cannot use further more resources to allocate to auto vacuum or vacuum in general, we can plan maintenance windows during the non-peak hours, and at that time we can set the resource allocation high for vacuum, and then we can vacuum the database, because vacuuming is important. Like uh, it cannot be neglected. So we can, if the database is busy, we can allocate a time maintenance windows on like daily or weekly basis, and then we can vacuum it. Okay, so it's the best thing to remove bloat for indexes, which will help in faster index scans and faster query execution in general. The next one is to avoid running manual vacuum or analyze for no reason. If you have configured auto vacuum, and I would like we don't suggest to run manual vacuum unless really necessary. So auto vacuum consumes much less resources, and it will be working regularly to free up the database load. So unless if the database is really busy, we do not suggest to run manual vacuum. Okay, so next thing is to consider the important and the critical queries that run very frequently on the databases, because that the tables that they access should be studied if they are having bloat, or what kind of search scans these queries are taking. So according to that, our settings should be in mind. Okay, so the last thing is performance after any vacuum or analyze should be studied. So database performance, like how database is performing after the vacuum or analyze, because turning on auto vacuum will not help. Auto vacuum is not magic that we can just turn it on and expect our database to be running at all health. Uh, we need to study our database after any vacuum or analysis happen, whether the vacuum helped the database or not, because sometimes reasons could be something else, like queries. The reason could be queries or other resource allocation or the specs of the servers. So like we so a study of the database is really important. A database should be studied all the time and taken care of. And like if you think you cannot troubleshoot well, or you need some expert guidance or advice from us, feel free to reach us. We are more than happy to help you with our database consulting as well as MDS services. Okay, so with that, we have come to an end. That was all from my side. Thank you very much for listening. If you have any queries or like suggestions, you can write us at info@mydbops.com. You can also write me a feedback on LinkedIn, like what you learn from this webinar and what things can be improved. I'm sure when things can be improved in this, you can please write me a feedback on LinkedIn. I would really appreciate that.
To subscribe our channel, press the bell button, like, comment, and share.